I want to find a portfolio that has the least risk. For example, suppose I use 1% trim mean as a measure of reward. And MAD as a measure of risk. Suppose I want my portfolio to have a 12% reward. So let me see. That's my, I want to make that 1%. That's my reward. Let's make that number 9. Okay. I may want that for a lot of different reasons. Remember some of the retirement planning exercises we have made? In one of the exercises, we calculated what should be the return that I get during savings stage in order to achieve all of my goals. Suppose that number is 9%. So I want my portfolios, let's say this is my 401k. Okay? I want my portfolios to have a 9% reward as measured by trim mean. Next question is, how many different set of weights can give you 9% reward? Any guesses? 9% or more. So let's see about that. For example, let's make that 50. 0, 0. Here's the portfolio. That's 50% US and 50% non-US and Canada. I mean, I just made those numbers up. I didn't know it. That's one example. I could actually vary those numbers around. The answer is there are infinitely many set of weights that would give you 9% or better reward. The question is, which one of those set of weights has the least risk? There are infinitely many set of weights that would get you 9% reward, but we want the set of weights with the least risk among those that has 9% rewards. You probably are thinking that's a rather complicated problem. Mathematically speaking, if your measurement of risk is standard deviation or variance and your measurement of reward is average, mathematically speaking, that problem is actually effectively linear. You can solve it with matrix algebra. But if your measure of risk is something like MAD or trim MAD, measure of reward is something like trim mean, you cannot. There is no explicit solution using even with matrix algebra. But as you know, we have numerical methods to solve these kinds of problems. To solve that, we're going to need something called, under Data tab, you need to have something called Solver. If you have used that before on your own computer, it will be there. If you have not, under File, Options, go to Add-ins. Down here, it's going to say Manage Excel Add-ins. Hit Go. Make sure that Solver add-in is checked. I typically check all 4 of them. And if you're using one of these computers, you have to do this every time you come here. But on your own laptop, you have to do this only once. Now, let's kind of get a setup going. I'm gonna say expected rewards. For now, I'm gonna put 9%. For actual reward, I'm gonna use trim mean as my measure. And I'm gonna use MAD as my measure of risk. So let me make that. So let's calculate the diff. The expected reward minus actual, okay? Now, I'm going to ask Excel using the Solver add-in, find me the set of weights that has the least risk subject to the constraint that the difference between the expected reward and the actual reward is 0. Okay? So I'm going to go to Data, Solver. What do you mean I'm group edit mode? Oh, okay. Apparently, I had picked more than one sheet. Data, Solver, okay. Unfortunately, I can't make that any bigger. So it has a few arguments. First thing is, what is your objective? My objective is the risk, okay. What do you want to do with that objective? I have 3 choices: maximize, minimize, and make it equal to a certain value. I want to minimize it. How are you going to do this? By changing a certain number of things. In this case, it is these weights, the 3 of them. Remember, the 4th one is determined automatically. Are there any constraints? Yes, I'm going to add a constraint, and I'm going to make the difference between expected and the actual to equal to 0. Or I could make actual is greater or equal to expected, but that's not going to change anything. Okay, so that's my constraint. By default, this little button says make unconstrained variables non-negative. That means I cannot allow, if they are non-negative, I cannot allow them shorting. For today's demonstration, you're going to have that box unchecked. Just hit solve. It has converged the solution. As you can see, actual reward is the same as the previous one. So this is 0.92. Okay. Control Z. If you remember our original set of weights, 30, 30, 20, 20. that has a higher risk. And turns out it also has lower reward. But that doesn't matter. That says if you want your portfolio to have a 9% return, the best you can do is put about 3/4 of your money on S&P 500. Okay. Also short the international. If you want your expected to be 12, you want to be a little bit more aggressive. We're going to redo this. Nice thing about solver, as opposed to goal seek, the last thing that you have done, it's still sitting there. All I have to do is hit solve again. As you can see, the risk that I could get is increased. I mean, I am getting 12% return, but I'm also assuming a higher risk. Turns out, at least for this set, you need to short the international even more. We'll stop here today on Wednesday. We're going to basically repeat this exercise for a lot of possible expected rewards. And for each of them, we're going to get a minimized risk. We'll then chart them, and we'll talk about that chart, which is kind of called the minimum variance boundary. So read about it. We'll talk about it next time.